Math Humans. We're going to do 5.1a today. We're going to be working with our fundamental trig identities. Our objectives are that we're going to use the fundamental trig identities to simplify expressions, confirm identities, and then eventually to evaluate functions. So I've pre-written them just to save us a little bit of time. In the front of your textbook, there is a list of all of the identities that we will be doing this year, including some that we will not be doing. I highly recommend that you write these down so that you can have them as an easy reference as we work through this chapter. So the first couple, actually, I'm just going to show you all of them. See if I can get them all on. Actually, I don't think I can. So let's go through these. These are the reciprocal identities. I never memorize these because if cosecant is the reciprocal of sine, then sine is 1 over cosecant. And so then I don't have to memorize those, but they're kind of handy. The Pythagorean identities are the three primary identities upon which everything else is based. And this is all based on right triangle trig. We talked about that in the last chapter. Quotient identities, tangent is sine divided by cosine, it's y divided by x, and then cotangent is cosine divided by sine, or x divided by y. The cofunction identities we'll use a little bit, but not that much, and basically what they want you to notice is that if I take sine and I translate it, pi over 2, I'm going to get cosine. And so the same, if I translate cosine, I get sine. If I translate tangent, I get cotangent. And so you get the general idea. The even-odd identities say if I take an angle and I do its negative rotation, what happens? And I also don't memorize these because I can manage that information by thinking about a positive and a negative rotation. So let's say this is theta, and this is x, and this is y, and this is r. So the sine of the original theta would be y over r. Well, then let's do the negative rotation, and let's take the angle down here. And so this would be a negative y. X stays the same, r stays the same. So then the sine of a negative theta is going to be a negative y over r. And so that's where they have the negative sine theta. So you don't necessarily have to memorize all of these. There will be more to use as we go along. The only five that I ever really expect you to memorize, you'll need to have these three memorized for calculus. These are pretty easy to manage just because we know that information, and then you need to know these too. Alrighty. I would still recommend that you take the time to write all of these down because you will need them later. Alrighty, let's do our first example. So for example number 1, I want to use the identities to evaluate the 6 trig functions, and we're going to be given that the secant of x is equal to a negative 3 over 2 and tangent is positive. So the first thing that I would do is draw my reference triangle. Okay, tangent is positive in 1 and 3. Okay, and then my secant is the reciprocal of cosine, right? So that means the cosine of x is going to be a negative 2 over 3. And I think that's easier to graph. So then I'm going to draw my reference triangle. Here's the negative 2. This is 3. And then I can figure out my y value by doing the Pythagorean theorem, and I'm going to get a negative radical 5. So now at this point, I have all of the information that I need. I chose this quadrant because cosine was negative. In the first quadrant, cosine is positive. That's how I knew to put this triangle here. So then if I do my 6 trig functions, I already have secant and cosine, right? So then if I do the sine of x, it's going to be a negative radical 5 over 3. The tangent of x is going to be y radical 5 over 2. They're both negative, so the signs cancel. I already have secant, I already have cosine, so my cosecant of x is going to be the reciprocal of sine, so it's a negative 3 over radical 5, and my cotangent of x is going to be 2 over radical 5. You'd never have to regurgitate anything that's given. So if I'm evaluating the 6 trig functions, they gave me 1, so I really only had to do the other 5. Alrighty, example number 2 wants us to use our trig identities. We're going to be doing trig identities for all of chapter 5 to evaluate the 6 trig functions. And this time we're going to be given that the secant of x is equal to 4 and the sine of x is positive. Okay, so secant is the reciprocal of cosine, so that means that my cosine of x is going to be 1/4. Okay, so then I'm going to go ahead and think about my triangle. That's a cosine, sorry. Sine is positive in the first quadrant. Cosine is also positive in the first quadrant. So that means that my reference triangle is going to go here. This is 1, this is 4. This is going to be the square root of 15. And I found that, again, by doing the Pythagorean theorem. And so now at this point, I can find all of my other ratios. So I know that the sine of x is going to be radical 15 over 4. The tangent of x is going to be radical 15, technically over 1. Okay. We already have secant, so my cosecant of x is going to be 4 over radical 15, and my cotangent of x is going to be 1 over radical 15. So it's actually pretty easy to find those missing ratios. For example number 3, we're actually going to do some work with the trig identities. So I have the sine of x cosine squared x minus the sine of x, and I want to simplify. So we're going to use our favorite F word. We're going to factor. You'll notice that these two terms both have a sign in common, so I'm going to factor it out, and I'm going to get cosine squared x minus 1. And if you'll remember the identity that says sine squared x plus cosine squared x is 1, it should be 1 minus cosine squared, but instead it's the opposite. So I'm going to make this be a negative sine squared x. So then this is going to simplify to be a negative sine cubed x. And then to identify, I would write that this is the simplify. And yes, the grammar is a little bit weird, but I think that is sufficient. All right. I would recommend that you write your Pythagorean identities on the top of your page when you're doing these problems. So I would write sine squared plus cosine squared is 1, and then 1 plus tangent squared x is equal to secant squared x, and then my third one is the cotangent squared x plus 1 is equal to cosecant squared x. And remember that all 3 of these identities can be manipulated by subtracting pieces from each side, and so then they show up in a lot of different forms. All right, so for example number 4, we're going to have 4 tangent squared theta plus the tangent of theta minus 3, and I want to do some factoring with this. And I'm just going to show you factoring and show you a method that you can use in case this gets overwhelming. We treat tangent just like it's a variable, and so we could think of this as 4x squared plus x minus 3 equals 0, right? And then I could factor, and I would do 4x and an x, and then I would do a negative 3 and a positive 1. I check to make sure I get the middle term. This is a positive 4 minus 3 gives me a positive 1. And so then if I wanted to finish, I could substitute my tangent back in. So 4 tangent squared theta minus 3 times the tangent of theta plus 1. So this would be the factored form, okay? I don't care if you do it with variables as long as you do the substitution when you're done, or if you just go straight to here. In the beginning, this seems a little bit weird, but the more of these types of problems that we do, then it will become a little bit easier. So the next example, example number 5, is going to say simplify. And we're going to have cosecant squared x minus the cotangent of x minus 3. So the thing that I need to notice about this particular problem is I have cosecant and cotangent. And if I go back and remember the identity of 1 plus cotangent squared x is cosecant squared x, and the more often you write it, the easier it is to memorize. So I need to have everything either in terms of cosecant or everything in terms of cotangent. I'm going to write it in terms of cotangent, just because. So if I take this ratio, cosecant squared, I can substitute the 1 plus cotangent squared, so I'm going to put 1 plus cotangent squared x minus the cotangent of x minus 3. So what I need to do now is combine like terms and put it in the correct order. So I get cotangent squared x minus the cotangent of x minus 2. Okay, and then if I wanted to simplify, I would factor and I would do cotangent x minus 2 and then cotangent x plus 1. So let me explain why we're factoring. Eventually, we will want to solve these quadratics, just like we would if it was a regular quadratic with x's. So I'm going to need to be able to put it in factored form to be able to solve the trig equation. For right now, all we're doing is simplifying, but eventually I will take each of these little baby factors, set them equal to 0, and then I'll solve. All right, example number 6 asks us to simplify, because you're going to see that a lot. And this time we're going to have the sine of x plus the cotangent of x times the cosine of x. So it's the same basic process. Cotangent is a little bit unusual. It's a function that's in terms of sine and cosine. So I would start by rewriting cotangent. So I'm going to write this as the sine of x. Cotangent is the cosine of x over the sine of x times the cosine of x. Okay? I'm going to need to put these two fractions together. So I'm going to multiply this one by the sine of x over the sine of x. As we work through Chapter 5, when you do math like this so that I can put my fractions together, you must show this math. You can't skip steps. So now if I simplify the numerator, I have sine squared x plus cosine squared x, that's cool, over the sine of x. Sine squared plus cosine squared is 1. So now I have, put my little equals in there, 1 over the sine of x, and this is the cosecant of x. So then I would report, I simplified, and it's going to be the cosecant of x. So it's actually kind of cool. So oftentimes in these types of problems, if you have mixed venues, like this is in terms of both sine and cosine, I would start by trying to rewrite cotangent. The other thing that I will tell you about this chapter is it's a little bit entertaining. So the identities can be challenging. The more you do, the better you'll get. The thing that's frustrating about identities is there's multiple ways to do a problem, but your process has to justify your answers. You always have to show all of the math that you've done, kind of like a geometric proof. You have to show all of the steps to prove that something is true. Alrighty, that's it for today. I will see you soon.